So it turns out today we're having some technical difficulties, so I'm going to make a video of today's lesson and I will link it to your Canvas page. As you can see, I'm at your Canvas page right now, and I'm going to go ahead and click on modules. We are in week 2. So make sure you do the check-in. I'm going to take attendance for today via the check-in. There should be 2 questions there. Nice and easy. Then go ahead and click next. And the lab today is a rebound lab. And what you're trying to do is you're trying to model movement via a graph and an equation. So you're going to collect data on the bounce of a ball, the rebound of a ball. Here are some objectives you can read through, a little bit of background which you can also read through. I will link the video right here, the one I'm recording right now. So here's some basic instructions. So let's talk about what you're going to do. Hopefully you've collected your bouncy ball and your measuring device over the weekend. So what you want to do is you want to take the ball and you want to release it from various heights, and then you're going to collect various rebounds. And you're only going to let it bounce once. For a lab, you need a minimum of 8 pieces of data. So be careful. You don't want to release the ball 8 times from the same height. You're only going to verify 1 piece of data. You need to release the ball from 8 different heights to get 8 different rebound heights. And you're going to place this data in a table. And I'll show you the formal lab write-up in just a moment. And then you're going to graph the data. And hopefully you all know from Algebra 1 and from chemistry that your independent variable goes on the x-axis and your dependent variable goes on the y-axis. So let me share my document camera. So I've gone ahead and drawn a graph here, which means you are controlling the drop height. So your drop height is going to go on the x-axis. And the unit is centimeters. Please, if you are using a device that uses imperial values, feet, inches, you have to convert to metric. And the dependent variable is your rebound height, which goes on your y-axis. Again, the unit is centimeters. That's a T. And hopefully you'll get something like this, which is going to yield a scatter plot. And from Algebra 1, you should know how to handle a scatter plot. What you're going to do is you're going to draw the line of best fit through those data points. And that is the line you want to get the equation for. And to do that, you're going to go back to the point slope equation. Y minus y1 is equal to m times x minus x1. This might bring back some nightmares for some of you. Use that equation to get the equation for this line. That is the goal. Can you collect data for a motion, graph it, and get the equation for that line? So let's talk about what you're going to submit. So you're going to submit a formal lab write-up. And here's the link to a formal lab write-up. Let's go over this. You're going to need a title. This gives you a little bit about that. You need a slight introduction. Again, state the issue. What are you trying to do? Give me a list of your materials. A labeled diagram of your setup. So draw a picture of what you're doing and label everything. The labels in your diagram should list the materials you have above. Give me a step-by-step procedure. It should be pretty easy. Not that many commands in this procedure, probably 3, maybe 4. Data table. Make sure your data table has columns and the columns are labeled with the units. Fill in your data. Make sure you use metric. You're going to do a proper graph, and in a moment I will take you to the graphing skill sheet. Calculation section. In your calculation section is the work to get the line. So your point slope equation and all the work, all the steps. The answer is the final equation. And then in your conclusion, I want you to read through the conclusion, and I'm going to see how you interpret that, and we'll talk about all this as a class when you return. So that's a formal lab report. Let's take a look at proper graphing skills. If I click on this link, it takes me to the graphing skill sheet form. Please read through this. It's going to take you through step by step. Let me highlight some important information. Number one, when you draw your line, don't just start at 0, 0 and go through all the points. It may not go through 0, 0. Your line falls where the data says it falls. And if that line doesn't go through the origin, then it just does not go through the origin. Make sure your increments on your graph are either 1 square, 2 square. You can actually do 4 or 5. And you are going to be using graph paper to create your graph, not by hand, and don't draw your graph by hand on computer paper, and don't use Excel. Make sure you label each axis with a unit, just like I showed you. Place a 1/2 inch by 1/2 inch square around each point. What this does is it signifies that there is error around this point. So if that's a data point, I'm going to do something like that. And I'm going to do it around each data point. Number 8 tells you how to get the equation for a slope. Again, this should be a review. Number 9 tells you how to draw your line. Number 10 tells you what happens if you have a data point that's way outside the trend. And 11 tells you how to title your graph. All of these things have to be fulfilled to get the points for a proper graph. So that's your goal today. At some point during either today or tomorrow, sometime this week, because we are going to continue on. If you get a chance, click that next button. We start the information on one-dimensional motion. This is a little basic background. By all means, this is not everything you need to know. It's just the highlights. Everything you need to know is in this reading assignment right here. And I sent an announcement that gave you a link to check out a textbook. A textbook is required. So make sure you grab a textbook, and there is your first reading assignment. If you click on next, you won't see anything because I haven't published it. But after when we meet again and discuss the Rebound Lab and discuss the literal equations, we're going to move on to actual collecting of physics and do a constant velocity lab. That's it. If you have any questions, just email me, and good luck. I can't wait to see what you submit.